Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 4.2, Problem 6. This is Section 4.2, Problem 6. It says maximize z equals 8x1 plus 10x2 plus x3 subject to 9x1 plus 6x2 plus 12x3 is less than or equal to 126. And then next is x1 plus 4x2 plus 10x3 is less than or equal to 220. And x1 is greater than or equal to 0, x2 is greater than or equal to 0, and x3 is greater than or equal to 0. Now, this is the type of problem that we did draw out before, where we sketch the feasible region, label the corner points, fill in the chart. We can't do that with this one because it has an x3. If it was x1 and x2, we could do it either way, either through a matrix or a simplex tableau or through the graphing of the feasible region. Once you go past two variables, you're into an x3, you have to do it with a matrix. So to turn this into a matrix, I'm going to have to get rid of the less than or equal to sign in the first constraint with the 126 after it, and also the less than or equal to sign in the second constraint with the 220 after it. So let me start by changing the first constraint into 9x1 plus 6x2 plus 12x3 plus S1 for slack, and I'm going to leave some space, and now instead of less than or equal to 126, I'm going to put equal to 126. Again, it's my goal to turn this problem into a matrix, and for a matrix I have to have a group of equations, not a group of inequalities. So the second constraint, which was x1 plus 4x2 plus 10x3 is less than or equal to 220, I'm going to add a different slack to that. So I'm going to write it underneath the first equation that I wrote, and I'm going to put x1 plus 4x2 plus 10x3 plus, and I'm going to just slide over a little bit and put s2. I don't want the s1 and s2 right over each other. They're different variables, and now instead of being less than or equal to 220, this is going to be an equation. It's going to be equal to 220. Now, at the very bottom of the problem was included x1 is greater than or equal to 0, x2 is greater than or equal to 0, and x3 is greater than or equal to 0. I don't need to put that in the matrix. I should see that it's there. I see that it's there. It doesn't need to go in the matrix. But what does need to go into the matrix is the object function, which already is an equation. It's z equals 8x1 plus 10x2 plus x3. I do not have a less than or equal to symbol here, so I don't need a slack. But what I'm going to have to do is rearrange the equation so that the x variables wind up on the left-hand side of the equal sign so they line up with the other equations that I'm going to be making as part of my matrix. So the 8x1 in the object function starts off on the right-hand side of the equal sign. I can easily move it to the left and it would become negative 8x1. So I want all my x1s to line up. Then the 10x2 that was on the right side of the equal sign of the object function will have to move to the left side of the equal sign, and when it does, it'll become a negative 10x2. And finally, the x3 that was on the right-hand side of the equal sign originally for the object function can be moved to the left. It'll become negative x3 or negative 1x3 if you like to have the 1. Does not need a slack. It already is an equation. And after I put everything over, it's equal to 0. But don't forget, there was a z in this. So notice I left a little bit of space. So where there is a plus, there's no slack, but there is a z, the object variable. So now I've rewritten the problem in a form that each part that I need is an equation. And each equation is written in such a way that the variables all line up with each other. So now I have 9x1 plus 6x2 plus 12x3 plus s1 equals 126. x1 plus 4x2 plus 10x3 plus s2 equals 220. And negative 8x1 minus 10x2 minus x3 plus z equals 0. Now they're all equations and all the variables line up. Now I can make it a matrix. So my matrix will need an x1 column, an x2 column, an x3 column, and that's enough x's. I'm going to need an s1 and an s2 column. I'll need a column for z. And the column for the stuff on the right side of the equal sign gets labeled RHS for right-hand side of the equal sign. So the top equation, the 9x1 plus 6x2 plus 12x3 plus s1 equals 126, becomes the top row of my matrix. In the x1 column, I just simply have a 9. In the x2 column, I have a 6. In the x3 column, I have a 12. In the s1 column, I have a 1. There was no s2, so in the s2 column, I put a 0. There is no z, so in the z column, I put a 0. And in the right-hand side column, I put a 126. Now, the second equation is going to become the second row of my matrix. The second equation is x1 plus 4x2 plus 10x3 plus s2 equals 220. In the x1 column, I put a 1. In the x2 column, I put a 4. In the x3 column, I put a 10. In the s1 column, I put a 0. The s2 column, I put a 1. The z column, I put a 0. And the RHS column, or right-hand side column, I put a 220. So now, one equation left, one more row of the matrix I have to put in. So the last equation is negative 8x1 minus 10x2 minus x3 plus z equals 0. So now in the x1 column, I put in a negative 8. In the x2 column, a negative 10. In the x3 column, a negative 1. Then 0 for the s1 column, 0 also for the s2 column, 1 for the z column, and 0 for the right-hand side column. So this would be the initial simplex tableau. So now what I need to do is find the pivot for this, pivot it, and see if I have the maximum or if I need to pivot it again. So to find the pivot, what I have to do is find the most negative value in the bottom row, and that's going to determine my pivot column. As I look in the bottom row, I have 3 negative values, negative 8, negative 10, and negative 1. Negative 10 is the most negative value in the bottom row. It's in the x2 column, so my pivot element has to be in the x2 column. Now, the pivot could be the negative 6 that's in the top row of the x2 column, or the 4 that's in the second row of the x2 column. The pivot cannot be the negative 10 that's in the bottom of the x2 column. The pivot can never be negative. It can never be 0. So to determine if it's the 4 or the 6, I want to evaluate the ratio of the right-hand side value over the pivot column value and find the smallest positive ratio. So in that top row, the ratio of right-hand side over pivot column would be 126 for the right-hand side number over 6 for the pivot column number. So 126 divided by 6 gives me a ratio of 21. The other row that I need to consider, the second row, the ratio of right-hand side value over pivot column value is going to give me 220 for the right-hand side value, divided by 4 for the pivot column value. 220 divided by 4 is 55. So the smaller ratio is the 21, right? For 21 or 55, which one is smaller? 21 is smaller. The ratio of 21 came from the top row. The number from the top row was the 6 that was in the top row of the x2 column. So my pivot is a 6. I need to pivot that 6, which means turn the 6 into a 1 and turn the rest of the column it's in, the x2 column, into zeros. So to start that, I'm going to get that 1 where I have a 6 by multiplying the whole top row by 1 over 6. So let me start a new matrix. I'm going to move over a little to the right. I'm going to label my column headings again. So I'm going to have to have an x1 column, an x2 column, an x3 column, an s1 column, an s2 column, z, and then finally the last column will be labeled RHS, again for right-hand side. And I'm going to make a new top row, which is 1 over 6 times the entire top row. Again, when I make a 1, I just involve one row. I multiply it times a fraction. When I make zeros, I have to add 2 rows together. So I'm going to multiply 1 over 6 times the entire top row of the matrix. So when I do that, in the x1 column, 1 over 6 times 9 is 9 over 6, which you can reduce to 3 over 2, or 1.5. All right, it is 1.5. In the x2 column, I'll have 1 over 6 times 6, which is 6 over 6, which reduces to 1. That's what I want. In the x3 column, 1 over 6 times 12 is 12 over 6, which reduces to 2. In the S1 column, I would have 1 over 6 times 6, which is 1 over 6, and it doesn't really reduce. In the S2 column, I would have 1 over 6 times 0, which is 0. The same in the Z column. In the Z column, I would get 1 over 6 times 0, which is 0. Zeros are certainly nice to work with. And in the right-hand side column, 1 over 6 times 26 is 26 over 6, which I actually already figured out and reduced to 21. Now, in terms of the other two rows of that tableau, I don't have to change anything yet. I'll change them in a minute when I make the zeros. The second row from the initial tableau can stay the way it is. It will stay 1, 4, 10, 0, 1, 0, 220. And the bottom row from the initial tableau can stay the way it is also. It will stay -8 under x1, -10 under x2, -1 under x3, 0 under s1, 0 under s2, 1 under z, and 0 on the right-hand side. Now, let me do the next tableau. I like to alternate the colors just to make it stand out. I'll put a line. I made the one in terms of the pivots. So the top position in the x2 column was a 6. I have now made it a 1. So to continue my pivot, the 4 that was in the center of the x2 column has to become a 0, and the -10 at the bottom of the x2 column has to also become a 0. So in order to do that, I don't want to change row 1 at all. So my next tableau down, I'm going to keep row 1 exactly the way it is. So I'm just going to recopy it. Row 1 of my tableau will stay 1.5, 1, 2, 1 over 6, 0, 0, and 21. Now, the next value down in my x2 column is a 4. I have to make it a 0. So to make that a 0, I'm going to write a little equation next to row 2, and it's going to be row 2 equals some stuff plus the old row 2. And I start that equation with row 2 because the value I want to zero out is in row 2. I end the equation with row 2 because it should begin and end with the same row. And I leave a spot in the middle that I describe as stuff. That stuff is going to be the row with the pivot element, which is row 1 for this problem, times the same number but opposite sign as what's becoming a 0. What's becoming a 0 is a positive 4. So the same number opposite sign is -4. So the equation I'm going to use to make my new second row is row 2 equals -4 row 1 plus the old row 2. That'll give me my new row 2. Now in the new row 2, what's going to happen in the x1 column, you're going to do -4 times row 1. That's -4 times 1.5. That's going to give me a -6. I'm going to add that to what's in row 2. So -6 plus +1 is -5. Then in the x2 column, -4 times row 1 is -4 times 1, which is -4. I'm going to add that to row 2. -4 plus +4 will make a 0. Then in the x3 column, I'm going to do -4 times row 1 is -4 times 2 is -8. I'm going to add that to row 2. So I'm going to add -8 and +10 is +2. Then in the next column, the S1 column, -4 times row 1 is -4 times 1 over 6. That's -4 over 6, which I can reduce. It's -2/3. And I'm going to add that to what's in row 3. So -2/3 plus 0. Oops, sorry, row 2. I'm going to add -2/3 plus the 0 in row 2 is -2/3. Zeros are very nice to work with. Then the next column, the S2 column, -4 times row 1 is -4 times 0, which is 0. And then you add that to row 2. 0 plus 1 is 1. In the Z column, -4 times 0 is 0. Then you add it to row 2. 0 plus another 0 gives you a result of 0 for the Z column. And finally, in the RHS column, you're going to do -4 times row 1 is -4 times 21, which would give a -84. You're going to add -84 and +220. So I think that's 136. Let's try that. Is 136. +136. So there's one of the zeros in the column that I want to zero out, and I want to zero out the rest of my x2 column after I made the 1. So I have another value in the x2 column at the bottom, which is now minus 10. It has to become a 0. So that negative 10 that I need to make a 0 is in row 3. So next to my row 3 in my new tableau, I'm going to write row 3 equals some stuff plus the old row 3. Again, I start that equation with row 3 because the value that needs to become a 0 is in row 3. I end the equation with row 3 because it should begin and end with the same equation. Now, I leave it blank. I call it stuff. The stuff is the row with the pivot element, which is row 1, times the same number but opposite sign as what's becoming a 0. What needs to become a 0 is a negative 10. So the same number opposite sign is positive 10. So the equation that I will use for my new row 3 is row 3 equals 10 times row 1 plus the old row 3. So now, 10 times row 1 is 10 times 1.5. That's 15. And you're going to add that to row 3. So I'm going to add 15 plus negative 8, positive 7. The next column is the x2 column. I'm going to go 10 times row 1 is 10 times 1, which is positive 10. And I'm going to add that to row 3. So I'm going to add positive 10 and negative 10, which is 0. The next column is the x3 column. I'm going to do 10 times row 1 is 10 times 2, which is 20. I'm going to add that to row 3. So I'm going to add 20 plus a negative 1 is positive 19. And the next column is the S1 column. 10 times 1 over 6 would be 10 over 6. And I can reduce that. 10 over 6 would reduce to 5/3. And I'm going to add that result of 5/3 to what's in row 3. So I'm going to add 5/3 plus 0. Plus 0 makes it easy. It's 5/3, positive 5/3. The next column is the S2 column. 10 times row 1 is 10 times 0. That gives me a 0. Plus row 3. So I'm going to add that to another 0. So I get 0 plus 0. The result of 0 goes in the bottom of the S2 column. And then the Z column. 10 times row 1 is 10 times 0. That's 0. Going to add that result to row 3, so I'm going to add the 0 that I got to 1. So 0 plus 1 is 1. And finally, the RHS column for right-hand side. 10 times row 1 is 10 times 21. That's 210. Going to add that result of 210 to row 3. So I'm going to add 210 plus 0. 210 plus 0 is 210. Now, as I look at the matrix that I have, or the tableau, it's the final tableau. I cannot pivot again because there are no more negatives in the bottom row. This is good. That means I found the maximum. Again, there are a few negatives in other places, but not in the bottom row. So the important point is I did find the maximum. So we started with an output of 0. Again, the output position on your tableau is the bottom right-hand position. We started with an output of 0, pivoted once, and the output went from 0 up to 210, and I can see that I can't make it any bigger. So my maximum, and we'll say maximum of 210 when x1 equals. Now my final tableau, when I look in the x1 column, I'm looking to see if I have a special column of all zeros and a single one, which I do not have. So the value of x1 is 0. x2, when I look in the x2 column of my final tableau, I do have a special column of all zeros and a single one. So the height of that 1 is going to tell me where to look for the value of x2 in my RHS column. So the 1 in my x2 column is in the top position. When I look in the RHS column in the top position, I have a 21. So x2 is equal to 21. And in my final tableau, x3 does not have a special column. It does not have all zeros and a single one. So the value of x3 is 0. And that's all you have to write. If you like, you can mention that S1, the first slack variable, has a value of 0 because it does not have all zeros and a single one. And the value of S2 actually is 136 because the S2 column has a special column of all zeros and a single one. The height of the one is in the middle position, and in the middle position in the last column is 136. But you don't have to include the slack. So your final answer is Maximum of 210 when x1 equals 0, x2 equals 21, and x3 equals 0.